All right. Hello.
Thank you for being here today, everyone. This is Ming Chow, and he is going to teach us about packet analysis using Wireshark. Take it
All
away.
right. I sound good. Everything's good. Ready to go. Ready to rock and roll.
Everything is good and ready to go.
All right. And you're going to be on this call, right? To make sure that just double check.
Yes, I'll be here the whole time. So
Excellent. Excellent. Hello, everyone. I'm Ming. Um, I pleasure to be here today. Thank you for all for being here as well. Um, hopefully everyone is be doing good. Everyone is staying safe. Um, so it's a pleasure to be here. First time doing a virtual conference, and I'll be talking about packet analysis using Wireshark. Um, it could be a subtitle is what do we do at the wall of sheep, and how do we um, do the wall of sheep at DEF CON, the security conference in Las Vegas. Here's my contact information, email address, Twitter handle. So this session is 1 hour. I'm going to try to talk. There's going to be a lot of gaps in this tutorial so that you can do real exercises, hands-on exercise as well too. So I'm going to talk hopefully for maybe like 20, 30 minutes at the most, but there's going to be like exercises for you all to do. It'll take like 10 minutes per exercise. Okay, so here's just a little bit about, if you're not familiar with the wall of sheep, um, at the DEF CON security conference and at the packet hacking village. So the wall of sheep in the packet hacking village, our goal is security awareness. We've been around DEF CON for over a decade. Um, it is the infamous wall. It is the infamous site that everyone likes to take a photo of, with all username and passwords being hacked at the being cracked at the conference. I'll show you a picture for what the wall is if you're not familiar with it. So how do we accomplish, do security awareness at the packet hacking village and the wall of sheep? We do a lot of interactive demonstrations. We do unconventional methods as well too. For example, a few years ago, we ran a peekaboo booth of images that were flying across the DEF CON network. In fact, that was a charity event as well. All the proceeds from, if you put a quarter in, that went to the EFF. We also had a juice jacking booth. We one time had a IoT gallery where a smart city where anyone can break. But our team is all volunteers, and we pay our own way out to go to DEF CON. So here is the infamous wall of sheep that is at DEF CON for decades. And as you can see, here is a list of, I forgot what year this was, logins, passwords, first 3 characters only, rest of the password censored out, what domain, what IP, was the username and password, the credential found on. I used that, and the protocol, network protocol that was used. And so this is not meant to be a, we're going to make fun of you, shame you. No, that's not the point, but the point really is security awareness. This is what happens when you log in to a website or email using insecure protocols, not using encryption. This is the danger of, accessing services where your username and passwords are sent in the clear. This is really so this is really an educational site. So the gist of today is, well, how do you do that? How do we monitor the network? How do we rip username and passwords out of the network traffic So this is we're going to show you the bread and butter tool that we have been using at the Wireshark for years. So what is packet analysis? I italicized the word packet because I'm going to speak a little bit more about that in an upcoming slide. So packet analysis, in very simple terms, is looking and understanding at the computer network traffic. Packet analysis is also goes by a number of different names and terms: network traffic analysis, packet sniffing, protocol analysis, packet tracing. They're all the same. They're all the same. So now, if you're not familiar, to delve deeper into the term packet analysis, what is a packet? Okay, well, before we get that, and I guess why? Why do packet analysis? And really, what's the point of this talk, this tutorial? Why you do packet analysis is it's actually for both good and bad. Packet analysis can be used for both good and bad for issues such as, troubleshooting networking, analyzing, rebuilding emails, files, chats, reconstruct images that were sent over the network, and of course, as I illustrated by the wall of sheep image, catch username and password, any other personal information that was sent over a network insecurely, which still happens up to this day. Okay, so I just put this in earlier today, and this was one of my favorite articles about that. Also shows the importance of packet analysis. It can be used to, let's say, lack of better terms, understand, how DDoS attacks are conducted and even what botnets do. And one of my favorite quotes is from Garrett Graff's article from a few years ago on Mirai. And that's the quote, and I had a good laugh at this. I had a good debate with Garrett, and he was a great sport. Carefully reconstruct network traffic and study how the Mirai code launched so-called packets against its targets, a little understood forensics process known as PCAP, packet capture data. So for you today, for everyone here, it's for you is going to be to have an understanding of this quote unquote little understood forensics process known as PCAP, packet capture data. We just talked about packet analysis, and a little bit down the slide, I'm gonna get into what in the world is this thing called a PCAP. Okay, so what is a packet? A packet, in very lay terms, is just a unit of data. When you go to a web page, when you go to stream video on Netflix, when you go on Twitter, when you play online games on an Xbox or a PlayStation, okay, all that everything that goes from your machine to over the network, it's all a stream of data, all a stream of data, all a stream of packets. Okay, so when you actually are streaming Stranger Things or Tiger King on Netflix, your video that you see is made up of many, many, many packets, many network packets. So a single network packet is really small in the byte level and the size level, but it contains a lot of information, lots and lots of information, including source and destination IP addresses, MAC address, protocol, and bits and pieces of data. Now, when you are going to a web page, streaming a video off of Netflix, that video is not, all that data is not in one packet. It's cut into many, many, many different packets. Okay, thousands and thousands of packets, if not hundreds and thousands, make up the video that you see on the screen. So a single packet, in a more technical details, a single network packet contains all the layers of what is called the open systems interconnection model. In short, the OSI model. So what in the world is this OSI model thing? Okay, so the OSI model, and this is one of the most, I would say, difficult topics when I teach computer cybersecurity. It's a conceptual framework, and there's also been a lot of debate whether this makes any sense or not. It is a conceptual framework that describes the functions of networking or a telecom system. Okay, there are 7 layers in the OSI model. Each and every layer has a certain responsibility. Okay, each layer is abstracted from the other layer. So one layer can do its thing without knowing what the following the layer below it does. A good picture is the one I posted. Each layer has a certain responsibility. Now, it goes from high level, layer 7, to layer 1, the physical layer. I hear a lot of analogies that a good way to understand the OSI model is to compare the OSI model with how the Postal Service system works. Okay, so at the lowest level, you have like the physical build, like your physical buildings, physical vehicles, including the mail trucks, airplane, you name it. And then the application layer is only the things that you see, like the mail, the envelope, and everything that you know. So in the OSI layer, the OSI model, layer 7, the application layer, is what you, the user, and we use on a day-to-day basis, such as SSH, web browsing, email. We see that, but we typically don't understand what happens under the hood, everything that happens under the hood, unless we actually delve into look at the network traffic. Layer 1, the lowest level, the physical layer, contains like cable hubs, wires, and the 2 most important layers we focus a lot on is layers 3 and 4. Layer 3 is networks, which is the networks layer. Think of it this way. The network layer gives the source and destination address, IP, but it doesn't contain any other data. No port and no network ports, no data. That's all responsible by layer 4, the transport layer. Okay, so this is layer 4 maintains the idea of a network port, you know, and also the payload as well. So it's a conceptual model, but it's also important to understand how to do packet analysis and ultimately to use Wireshark. So going back, remember that article I showed you from Wired Magazine mentioned this idea of a PCAP file. So a PCAP stands for a packet capture file. So .pcap is the file extension of packet captures, and it's used many different applications, many applications such as Wireshark, which I will present today. So on the grand scope of things, 100 megabyte PCAP file contains tens of thousands of network packets. So what we've gone over, so we've gone over packet analysis, we've gone over a packet, we have gone over a PCAP file, which contains many packets, and we also can talk about the OSI model as well. So 4 big ideas. So how do we actually, quote unquote, see this? Like, what does this all mean? Like, can we actually have a practical working of everything that we talked about? And the answer leads up to Wireshark. So what is Wireshark? Wireshark is an open source and free packet analyzer. It's graphical, platform independent, and it is arguably, if you're doing network security or networks in general, it's arguably one of the most important tools to use. Wireshark contains many features, including filtering, reconstructing conversations, even just quick shortcuts to even do statistics. to get domains, IP address to domains. And so the website is Wireshark, https wireshark.org. So how does Wireshark look? The Wireshark may look intimidating when you start, and it is. And there's even new stuff that I learn all the time. Very important to note is, you know, one thing I am very, very mindful of is the problem of imposter syndrome in cybersecurity. Things are complex. There's a lot to learn. There's a lot to do. Yeah, but keep chugging. Things are more complex. We all have it. It's okay. We all have it, and this is why I'm giving this presentation is, you know, to help you all out. And even for me, we're not experts. We're not like experts. We're still learning stuff all the time, just so you know. So going back, here's the Wireshark interface. Think of it as, break it down into 4 pieces. Main toolbar. There is a main toolbar where you can do things like filtering, open up PCAP files. The big one is going to be the list of packets. It's the packet list pane. This is where you get like a good preview of packets in a PCAP file. You will see source and destination IP addresses, protocols that are being used, and also even bits of data, including port numbers and you know, even payload. Below the packet list pane is going to be packet details. Remember I talked about the OSI model that break down into different layers. So one single packet has an encapsulation of all those conceptual layers. And below the packet list pane, the packet details is where you actually can see a breakdown of all the, well, you know, all the layers of the OSI model in a packet. And last but not least, the last and final section of Wireshark is packet byte details. This is where you see a packet in its raw binary format. Okay, so here is the first exercise we're going to do to get you accustomed to using Wireshark and with a PCAP file and with packets. The first exercise that we're going to do is, well, open up a simple PCAP file in Wireshark. First and foremost is to download a PCAP file that I have at https://www.cs.tufts.edu/comp/116/simple.pcap. It's a very small file. And one thing, as you can see from the URL, I'm an associate teaching professor at Tufts University, Department of Computer Science, and I teach the cybersecurity course over there among a whole bunch of other courses. And so download the file, and we're gonna take like 5 minutes. So there are 1, 2, 3, 4, 5, 6 questions, 5 questions plus 1 bonus. And the question number 1, how many packets are there? Question number 2, what networking protocol is or are used in this PCAP file? Question 3 is, what is the source IP address? That is this, what is the source IP address of the machine I'm using? What is the destination IP address of the computer I am trying to talk to? Question number 5 is, what port number is the source used to communicate with the destination? Or what port number is the destination listening on? And bonus, if you are familiar with basic networking, do you notice the 3-way handshake? I'll give you a few minutes. Take a look at this. 49.
Hey, just checking, Ming. This is when
Yep.
people are doing their exercise, correct?
Yep. What?
Awesome. We just wanted to make sure. So
Yeah, I'm still here. I was a little worried about that. I was like, yeah, it's a little. This is kind of weird because you can't see the crowd.
yeah, I would definitely recommend saying something every couple minutes just in case people.
Yeah, just to make sure I'm alive, just to make sure that we're okay. Well, I
Yes.
can't play dippy music. Well, that's the thing.
Yeah, it was more just to like if people hop onto the YouTube, they're not just really confused about why there's no noise. So,
Yeah. Yeah, this is the one thing that is interesting because like, yeah, this is good that because we're going to be doing virtual conferences, I think, for the long run. And this is good practice. Say, okay, what works, what doesn't work.
yeah, for sure.
Yeah,
Awesome.
no audience. Yeah.
Continue doing what you're doing.
Yeah, yeah, yeah. All right. So, I forgot we are on YouTube, right? Live.
There's about a 20-second delay in like what we're doing and versus what's on YouTube. Uh,
Hmm.
but yes, we are virtually live on YouTube.
So this is recorded and everyone can follow along, right?
Correct.
Oh, okay. So why don't I do this? I will, let's see if this thing works. Gotta download that. And click on this. Yeah. So I'm gonna save this simple.pcap file onto my desktop. Works. Okay. So let me quit out of my browser. And now let me open up Wireshark. I'm on a Mac. There you go. So here's Wireshark. Lots of stuff here. We're going to do a file. We're going to do a file open. We're going to go to our desktop. We're going to open up simple.pcap that we just downloaded. Now, before we do, look at the size. It's only 715 bytes. Pretty small file. Open up simple.pcap. There we go. And just a quick review of the Wireshark interface. Here is our toolbar. Now we're going to be using a toolbar in the next in a future exercise, the third one. Here is the pane that lists a preview of all the packets in the simple.pcap file. Here is a breakdown of a packets, all the layers. So let me show you. If I click on the first packet, which is number 1, here, then the all the different layers, you can see and expand all the details on a particular packet. If I mouse and I actually click on, let's say, the second packet, you can see the details of the packet will change. Third packet, fourth packet, fifth packet, 6, 7, and 8. Okay, so there are 8 packets here. So you go back to the slide. How many packets are there? Number of rows. 8 packets. There are 8 network packets in this PCAP. Small. Question number 2. What networking protocol is used? Back to Wireshark. And there's the consistency here. And the protocol that's being used for the for this set of network traffic, TCP. TCP protocol. Now, sometimes when you open up another set of network packets, you'll see different protocols. Sometimes you see layer 7 protocols such as HTTP, which is web browsing, or FTP, the file transfer protocol. In fact, that's actually going to be the next exercise that we're going to do. Question number 3, what is the source IP address? Well, interestingly enough, this could be a confusing question because there are actually not one, but 2 different source IP address. One is 192.168.1.3, and the other one is 192.168.1.8. So which one is which, really? So which IP or what IP address belongs to what? It's interesting because if you actually, let's say the second packet on the set, the second packet on the set where the source destination source is 192.168.1.8 and the destination is 192.168.1.3. So what computer is being used for what? But interestingly enough, you can actually get all that information if you actually take a look at the details of each and every packet. In fact, let's say we have clicked on the second packet. And interestingly enough, if you take a layer 2, you can see destination, you can see the MAC address for the destination and also the MAC address of the source as well. But as you can actually see what Wireshark can do, it actually will spell out, can spell out what kind of device is being used. In fact, in this case, the destination is an Apple device and the source is a Raspberry, well, it's a Raspberry Pi. Now you click on the first packet and I'll go back to packet number 1 now. Packet number 1, the source is an Apple device and the destination is a Raspberry something. And so what really is happening is that the source is actually like a MacBook or MacBook Pro, and the destination is a Raspberry Pi. So the answer I was really looking for, the source IP address is 192.168.1.3, and the destination is 192.168.1.8. Okay, so that answers questions number 3 and 4. Question number 5 gets interesting. What port number is the source using using to communicate? The source in this case is going to be 192.168.1.3. But what's the source being used to communicate with the destination, or what port number is the destination listening on? This gets interesting because that information can be found here in the information column. Okay, and in the information column, you see there's 2 sets of numbers. There's 2 numbers here, but there's an arrow sign, an arrow sign pointing. So this is the source port. That's the destination port, and so the destination port that I am trying to communicate with to the destination at 192.168.1.8 is 7777. And you can see that here. And then, of course, and then the second packet, when the Raspberry Pi, which is the machine that I'm trying to talk to, it goes from port 7777 back to my port that is on my Mac. Okay. Here's a bonus question. Do you notice the 3-way handshake? If you're familiar with TCP, the TCP 3-way handshake, it works like this. It is sync, sync-ACK, and ACK. Think of it as almost like a telephone conversation. The TCP 3-way handshake, when you're trying to give a telephone call to another party, is hello, and then you dial your number. The other party is going to say hello. Then, of course, when you hear the hello, you say, oh, hi. So you can see it also in the information column. You see the 3-way handshake by sync, sync-ACK, and ACK. You can see that in the packet in the info column, Wireshark. Okay, so this is the first opening exercise to open up a simple PCAP file, hopefully to give you acclimated with Wireshark. Let's do another fun, real example now. This time, we're going to do an exercise on how to reconstruct a conversation in Wireshark. Now, what does that mean? Here's how you reconstruct a conversation in Wireshark. Reconstructing a conversation, this also includes like audio file, pictures, chat logs, videos. Okay, generally speaking, how you reconstruct a conversation in Wireshark is this. Assuming that you've opened up a PCAP file, click on a packet, any packet, it'll be highlighted in blue. Right-click on a packet using your mouse, go to follow, and then follow one of the following stream depending on the protocol that's being used. TCP stream is the most common one. Here's a picture. Yeah. So the next exercise we're going to do is extracting pictures. This exercise builds on exactly what we just talked about moments ago, how to reconstruct a conversation in Wireshark. This time I have a little bit more longer PCAP set that has a number of audio, a number of, let's say, pictures, audio files, data, you name it. Okay, and your job now is to extract the pictures and actually videos as well too. I think there's a couple videos in this thing. What insecure protocol was used to transmit pictures on the network? How many pictures were transmitted? And question number 3 is extract one of the pictures that was transmitted. Here's a hint. You want to show and save the picture as raw format. Give you a few minutes for this one. I'm going to download the PCAP set myself. Brave. Using Wireshark. Ooh. I'm going to open up set1.pcap. Now, as you can see, set1.pcap a little bit bigger, 6.69 megabytes. Pretty sure this won't have 8 packets in there. There you go. So if you want to do exercise 1 all over again, but on this packet set, on this PCAP file, how many packets are in this PCAP file? In this case, it's going to be 7,362 packets. Quite a big jump from 8. What protocol is being used to transfer files? You can see there's a lot of TCP, but there's also a lot of file transfer protocol, FTP, as well, in which the data is always sent in plain, is generally always sent in plain text. So there's some data, there's some file transfer that's happening here in this PCAP file. Oh, there's also an SSH as well. But interesting, as you can see from the information, the info, there's quite a lot of information, data that you can actually take a look, that you can see in plain text, that you can see with with your own eyes. Let's click on this one that has a user with Jericho. What you can do is right-click, follow, and let's follow the TCP stream on this packet. There you go. Interesting. As you can see, when I just recreated the TCP stream, you can now start to see that, well, the communication trail between the two computers, one at 192.168.1.231 and the other computer at 192.168.1.207. So interesting. You see the first set of the first thing that you see when you follow the TCP stream is, oh, you see some information happening. You see a username and you see a password. That happens to be the username and password in plain text, sent in plain text to the FTP server at 192.168.1.207. And then you see this log. You see the login was successful. You see that there's been a number of data transfer complete. 1, 2, 3, 4, 5, 6, 7, and then it all quits. Okay, interesting. Now, that wasn't what I asked. I didn't ask for what username and password we use. I asked to reconstruct images and pictures and media. So what insecure protocol was used to transmit the pictures on network? The answer is FTP, the file transfer protocol. How many pictures were transmitted? Let's see that one. Now let's answer that. How do we do that? Well, one way you can try to extract data is go and find a packet. Oh, by the way, let's clear the filter so we get to see all the packets in this PCAP file. Maybe the one way to do it is go all the way up and look for a packet that has the protocol FTP-data, and then do a right-click follow TCP stream on it. There we go. Here, this looks like a file that got transferred. Not very human readable, not human readable. There's some elements that are, like at the top, MP42 MPMO, video handler. Let me give you some clues that this is a media file, but it looks like a video of some sort. So going back to my slides, one of the hints I said was show and save the picture as raw format. Let's see what happens when we save this as raw format. So how you save a built communication in raw format is show and save data as. There's a pull down menu. Save it, go and select from ASCII, CRA, hex dump, save it as raw. And then do a save as. I'm going to save this on my desktop. I'm going to say output 1. Okay. Now, if I go back to ASCII, I can see the data in ASCII. Another way to actually see all the files that were in this communication trail is to go up and down this thing called stream. So now, if you go all the way back and go to stream 0, I think that's the SSH, but stream 1, you saw this moments ago. Stream 2 is what we just did we just saved as raw format onto our desktop. Let's go back up. All right, so here's another file that got transferred between the two computers, 192.168.1.231 and 192.168.1.207. This time, again, not a lot of information is human readable, but I do see a PNG here of some sort. Why don't we do a show and save data as raw format as well? Do a save as on my desktop and say output 2. Go back to ASCII. Let's go to stream number 4. Stream number 4, we have another picture here. Save as, output 3. Back to ASCII. Ooh, interesting. This time around, you see a file that got transferred, and it is readable text. Lots and lots of readable text in this PCAP file. We could save it as raw, but what's the point when we actually can save it as ASCII, readable ASCII? I'm going to save this as output 4. On a side note, this was Dan Gear's 2014 Black Hat keynote speech. Let's go to the next stream up, number 6. Aha, I see another thing, media file produced by Google Inc. Interesting. I'm going to save this as raw format. Go back to ASCII. 7. Oops. No, that doesn't happen so much. My Wireshark crashed, which happens every so often. I'm going to do an ignore. That's fine. So where were we? Follow TCP stream. Go back to stream number 2, 3, 4, 5, 6. I'm going to do a file save as. Okay, here's another one. Oh, crashed again. I'm going to ignore. But it's okay. Let's actually take a look at what we saved on our desktop. Output 1, 2, 3, 4, 5, and 6. What happens if we actually do a get file open? Output number 1 happened to be a video. Okay, that works. What's output number 2? Can we open it? Double click on it? It's a nice picture of Leslie. What's output number 3? Another picture of Leslie. What's output number 4? Dan Gears talk. What's picture number 5? Or what is audio number 5? Another video. What's output number 6? Up that video again. Yep, all those were in the PCAP file. Set number 1. I want to go back and actually want to save, go back and do a follow TCP stream. Let me see if I can go back to 7. Output 6. My place. And what's the stream number 8? Ooh, this looks something like a PDF here. Save as. Output 7. And that's it. Can't go up, can't go down anymore. All right, so what are the remaining files that I downloaded? I don't know what this is. Aha, look at this. The last and final file that was in that we extracted from that PCAP file, set 1. Not a picture. Well, close enough. It is technically it is an image file. The PDF on Malware Unicorn. So how many files did we actually, how many pictures did we get? 1, 2, we got 2 pictures, 1 text, 2 videos, 1 PDF, and I have no idea what happened here. Okay. So going back to the slide, it's, I think we got 2 pictures, 2 videos, 1 PDF, and 1 text. Okay. So that's how you extract pictures from a PCAP file. Generally is right click, follow TCP stream, and save the content out to raw format. All right, we're going to do one more exercise. And before we do one more exercise, I want to give a little bit of a background information that you will need. It's called Base 64. Base 64 is an encoding scheme. So what Base 64 is used for is to represent binary data, as you saw in the set1.pcap that you downloaded and analyzed. It's used to represent binary and ASCII text format. Very important to note, and I can quote many people on this, Base 64 is non-encryption. Base 64 is non-encryption. Sadly, it is always misused. Base 64 is not encryption, it is encoding. Encryption is a totally different thing, but encoding is just representing goods going from one format to the other, usually for safety purposes. So you may be wondering, why in the world am I actually showing you Base 64? Well, in basic HTTP authentication, that is in some username, like some username password fields, the username and password is not encrypted. It's just merely encoded in Base 64. A request contains a header field in the form authorization : basic, and then some sort of credentials, where credentials is the Base 64 encoding of ID and password joined by a colon. Okay. So one thing that I also need to make clear on the slide is Base 64 has an encoding, it's an encoding scheme, and also has a decoding scheme as well. So what we want to do is, if we ever find a Base 64 encoded string, we can decode it using some decoder that we can get online. So why is this important? Well, this problem, username and passwords. The exercise that we're going to do is going to be downloading a PCAP set. This is legal at HTTP. Download this PCAP file. And this PCAP file will contain username and password pairs. This PCAP file will contain username, password pair, credentials sent in plain text. Okay. First question is, what protocol was being used to transmit the username password pairs? Question number 2 is, what is one username and password pair in this PCAP set? And the hint is, this time we're going to use a toolbar. We're going to use a toolbar to help us find username and password pairs. And there's also a bonus question as well too. Is the username and password pair valid? Why and why not? There is one question I did not ask, is question number 4. It's kind of an obvious, goes without saying, how many username and password pairs are there in this PCAP set? Let's find out. So let's go to Wireshark. And let's open up on my desktop, or save it on my desktop, set3.pcap, which I asked you to download. Now, this PCAP set has 170 packets. 170 packets. So now, question number 1 is, what protocol was used to transmit the username and password pair? Okay. Wait a minute. What is one password, username, password pair in this PCAP set? Use edit find packet. Okay. Question 1 and number 2 go together. But what we want to do this time is this. Take a look at the previous slide, something I talked about Base 64. In Base 64, basic HTTP authentication, a request contains a header field of the form authorization : basic. Maybe we need to look for the string authorization : basic in this PCAP set. So let's go to File. What did I say? Edit find packet. Edit find packet. Or the other way is, you can click on the little magnifying glass in set3.pcap. on the toolbar. So authorization basic is a string that we want to look in this PCAP set. Okay, is that it? Not really. We need to make sure that we are looking for the string authorization : space basic. We want to look for packet details, not a packet list, packet details containing the string authorization : space basic. And we also want to search for narrow and wide. You want to actually click on case sensitive? Sure, why not? Let's try that. Let's try to see if we can find anything. Click on find. Ooh, interesting. It found something. Here it is. Here it is. It found something. Packet number 60. Packet number 60. As you can see, the source IP 192.168.1.3, IP address is 130.64.23.35. Transferred using HTTP, the Hypertext Transfer Protocol. In lay terms, web browsing. Not HTTPS, HTTP. HTTP by itself has no is insecure, plain text. But if you actually take a look at the packet detail, at the byte level of the details, you can take a look. Here it is, authorization : space basic, and then you have this encoded string, which we can decode to get the username and password. Take a look at the details on the packet and breakdown of each and every layer. There we go. Found a packet with authorization : space basic. And then we have a string here. But what is the username and password? I'm going to do a copy. I'm going to copy this. I'm going to right click on, I can right click on authorization basic : space this encoded string. I'm going to copy this as printable text. Sure, why not? The reason why I'm going to do that is because I need this information later. I need this information. But what you can also do, what Wireshark also does for you, is it actually even decode the encoded string for you. So we have a credential here. Username is B. Rogers. The password is they played with great character. Interesting. Remember how I actually copied that value, that string from the PCAP set, from that value? Authorization : space basic. And I got a space and I got this hash. Well, not hash, this encoded string. Sorry, I misspoke. Here's an encoded string. If a string is encoded, can I decode it? The answer is you should. You go to a base64 decoder on the web. Base64 decode and encode online. Let's paste decode from base64 format. So let's paste in our base64 encoded string and hit decode. And you can see the base64 encoded string gets decoded into B. Rogers : they played with great character. So we found one username password pair in this PCAP set. But there's a follow-up question. And this is the important question when we work on the wall of sheep. Is the username password pair valid? Why or why not? And so to answer this question, you need to go back to the previous exercise and something that you learned, which is to verify the conversation, you want to right-click on this packet, the one that contained the base64 credential encoded, follow TCP stream, or you can do HTTP stream. Let's try the HTTP stream because, you know, see. Interesting. You can see the username and password encoded in base64 we just saw moments ago. But the result is interesting. You get an authorization required, HTTP status code 401, but read the text carefully. Authorization required. The server could not verify that you are authorized to access the document requested. Either you supplied the wrong credentials, bad password, or your browser doesn't understand how to supply the credentials required. And so the answer is, when you see this type of message after a username and password is entered, usually not good. And so the answer to the question is that username password pair that we found, B Rogers, the username, they play with great character, password, not valid. Doesn't look good. That won't be going onto the wall of sheep. But wait a minute. Are there any other username and password credentials in this PCAP set? Let's find out. Find again. Found another one. Found another one. This time, like double click on the packet, which you can, double click on the packet, you can see the base64 encoded credential, Wireshark, where I can decode it, Moyes, I am a football genius, as the password. Right click on this one. Now, is this credential valid? Right click, follow HTTP stream. Again, you get a 4.1. I'm going to copy the string, ZG1, whatever it is. Go to a base64 decoder on the web, decode, Moyes, I'm a football genius. So this username and password credential is not good either. Let's do one more. Found another one. This time, credentials, A. Ausler, idiot expert, IoT expert. Follow, TCP stream, interesting, bad as well. That it? Well, it looks like that's it, because we're going back to the top. And the answer to that question is, we saw not one, not two, but 3 HTTP username password pairs. We found 3 of them. None of them were valid. So these are 3 exercises that we just did. So where do you go from here? Well, what you can do is the next step is quite a lot of opportunities, quite a lot. You can actually do further network sniffing. You can actually try to grab packets on the network, on your network at home, and then you can do like things like validate packets. You can even, sniff your own network, and which is totally different talk for another day, to reconstruct files such as images and MP3s. We're not sure if DEF CON is going to happen, but yeah, when DEF CON and the Packet Hacking Village, if when it goes back up, volunteer. You're all welcome to volunteers. We're always looking for volunteers at the Wall of Sheep and the Packet Hacking Village. In fact, we have a number of events at the Packet Hacking Village at DEF CON, including the Wall of Sheep, including brand new Packet Inspector events to do more of these type of activities. There is a contest that we put in every year at an intermediate level called Packet Detective. Okay, Packet Inspector, what we just did was basically a Packet Inspector level. And then if you really, really want to hone your skill and perhaps win a DEF CON Black Badge, which can be valued at $1,000, lifetime admission to DEF CON, enter Capture the Packet, which is a Black Badge event. So the slides are going to be up. And in fact, I do have another exercise for you if you want to follow, but this one is a real set of packets from the DEF CON conference. I'll let you play around with this. Same idea as what with the last exercise that we did. And there's also an appendix. If you don't like, you can also do a text-based version of Wireshark using T-Shark. And that's that.
Alrighty. Thank you so much for this. It was awesome. Yes, there was a lot of requests about your slides, and everybody wants to see them. So if you'd post them in the slides and links channel in the Discord. There also was a few questions inside of Discord, but we're unfortunately out of time for this right
Yep.
now. So if I assume you'll go and answer them in the Discord. Thank you so much.
Excellent. Thank you so much, everyone. Stay safe. Pleasure.